Hey, how's it going, guys? Welcome to my YouTube channel where I share with you my programming journey and experience and knowledge. In today's video, I will be sharing something very sad with you. And guess what? I was hacked. Yes, I was hacked over the weekend and I lost about $3,000. And everybody has been saying, hey, what's up, Felix? You good? How comes you were hacked? What happened? Everybody's been asking me what happened, what happened, what happened, what happened. Well, I decided to make this video to explain everything that happened, how it happened, what the solution is, and of course, the aim here is to make sure that if you are a developer, that you don't make the same mistake I made. And of course, because what really happened, I don't really want to call it a hack because it's not really a hack. I will prefer to call it an exploit. Why do I call it an exploit? It's an exploit because it's actually wasn't supposed to happen, because it's something very basic, and the hacker, whoever he is, actually discovered a loophole in my smart contract and exploited it and then stole all the funds in the contract. So let's dive right into it and see what really happened. So what is really the project? The project involved in this hack is actually a staking smart contract. A staking smart contract, as you can see, people stake their tokens, and after some certain amount of days, they get their rewards. After certain amount of days, they are able to unstake and get their reward. So the hack actually happened with this 15-day stake, where people staked about 6.5 billion tokens, and they were supposed to get 50% of that in 15 days. So that is the project, and the smart contract for this project was hacked because I got a bit careless. Yeah, not a bit, I actually got a lot careless, and the hacker was able to figure things out and exploited the project. So what really happened? Now what happened is this: for the smart contract of this project, we wanted a way to validate transactions for the project, because if you look at this stake right now, they are to get 50% of whatever they staked. So these 50% of whatever they staked. Now the problem is that Solidity doesn't really support floating points. So if someone eventually staked any amount that involves is floating points, it's going to give an inaccurate value. For example, in Solidity, you cannot say, let's say, calculate 1.5% of something. The 0.5 is going to be ignored normally by Solidity. Why? Is because Solidity currently doesn't support floating points, and this is a feature that I expect that I'm actually hoping that future Solidity updates will support, because it's really a problem. You can't really do any calculation that involves decimal points in Solidity. So in order to prevent getting the wrong figure, given the fact that Solidity doesn't support floating points or decimal points, we have to calculate the rewards, the staking rewards for every user from the front end. This is actually a React app, and in this React app we have these function. Let me say let me see. Okay, good. We have this function get earnings. Okay, now what this function does is to take an amount. It takes the amounts the user had staked and then the percentage that I want to calculate, and then it actually calculates the percentage for us and then return the final results. That's what this function actually does. So we are doing this on this calculation on the front end because Solidity does not support decimals. So if we had a situation that involved a decimal calculation, it's going to return an incorrect value for that particular user, and of course, we don't want that to happen to our project. So our resolve was to do the calculation on the front end and then pass the amount to the smart contract so the smart contract can pay when they try to withdraw. So but to do this, we need to ensure that this transaction is actually coming from the smart from our website. Like we needed to make sure that this transaction is not actually coming from any explorer like BSC scan or what have you. So we needed the way to make sure that this transaction will actually come from the website, and to do that we set a password. Now that is the genesis of the problem. So we set a password, an encrypted password, which was supposed to be passed to the smart contract. If you look at this right here, we have this encrypted password right here. So when we are deploying the smart contracts, let me get that. So this is a smart contract. If you look at the smart contract right here in the constructor, okay, we actually have a private variable. Okay, let me get that. Okay, so we actually have this private variable called strings. Okay, it's a password. Now we initialize this private variable in the constructor. Okay, so we actually going to pass our value when we are trying to deploy this contract, and the value we passed to it was this one here, this encrypted stuff here. So we passed that to the smart contract. We stored this in the smart contract. So what happened is that when the user calls the withdraw function, the unstake function rather, we send a transaction to the smart contract. Let's look at the withdraw function in the smart contract. In the smart contracts, we have this withdraw function. Okay, now this withdraw function, if you look at it, it takes the pool ID, and then it takes an amount, any amount at all, and then it takes our password. Okay, it takes our password. So if this password, if you look at in this line 319, we are actually using the KeyCAC 256 encryption algorithm, and we are saying that if the encrypted password matches the encrypted version of the string variable that we had stored in this contract, then transaction is valid. Now this is the big problem here. This is the big problem. This is an inappropriate way to implement this, because we are saying if the val that is being passed to this smart contract matches the password that we have stored in the contract, then transaction is valid. Otherwise, it should say suspicious, whatever, suspicious activity detected. But this is actually inappropriate, and I'm going to explain that as we proceed. So let's go back to our React app. Now we have, this is our password. Like I said, we have it stored in our React app, and we also had it stored on the smart contract as a private variable. So now let's look at the onStake function on the private variable on the our React app. So now let's see, get stake. No, this one, not this. Okay, not this. Okay. Let me just look for it. Good. Now this is our onStake function. Okay. Now if you look at this function, is actually calling on this line 625. It's actually calling the withdraw function on our smart contract. Okay, now it is passing, of course, our smart contract requires we pass an ID, so it is passing the ID. Our smart contract also requires that we pass an amount to it, the amount it's supposed to pay, so we are passing this amount here. And then, okay, not this one, sorry, I'm actually looking at this. So an amount it was supposed to pay, and then we're supposed to pass a string to it. Now what happened? The exploit, now we're supposed to pass it, from our smart contract, we're supposed to pass what we call that withdraw function, supposed to pass the pool ID, we pass the amount, and we pass the password. And when the password matches, then funds get sent. Okay, so this is because we have done all of the calculations and everything from the front end, because Solidity doesn't support floating points or decimal points. So how did the hacker figure out the password? Because for the hacker to have transferred all of the funds in this smart contract, they definitely had to figure out what the password is, because this function here, withdraw function, requires a password, and only the React app knows this password. So the mystery becomes, how did the hacker get the password? Someone would like to say, oh, I stored it as a private variable, so it's not even supposed to be visible anywhere. Well, that was our confidence too. And also we're thinking, hey, we had it encrypted with keycard 256, so yep, it's not supposed to be easy to find out. That was our confidence too, but we were wrong. So let's dive into the next thing. How did the hacker get the password? Now, the hacker got the password in a very, very simple way. Very, very simple way. Now, the hacker is obviously had obviously staked in the contract also, and also had withdrawn his staked tokens in the smart contract. Having withdrawn his staked tokens in the smart contract, he of course took note of the contract address that sent him the tokens. I mean, he withdrew legitimately, first of all, from the website. And then, being a hacker, he took note of the smart contract that sent him the tokens, which was this smart contract. Okay? Now, sorry. Now, it was this smart contract that sent him the token. So what he did, He just clicked on transactions here, and then looked for the transaction. Let's check for it together. Then we have this transaction here, withdraw. Okay, had this transaction here, withdraw. So what he did was to click on this hash here to open up this transaction that led to the withdrawal of his stake. Now, if you look at this transaction, a lot of tokens they send, blah blah blah, but this is not important for us. You can see he had to click on to view more. He had to click on that. Clicking on this to view more. Now, when he clicked on this to view more, we had the transaction encoded here. This is an encoded transaction that was passed from our React app to the smart contract. All he had to do was to click on decode input data. And when he clicked on decode input data, it showed him the parameters that were passed to that function. What I mean is the parameters that were passed to our onStake function when the user was trying to unstake. Because if you recall, our smart contract requires that in order to withdraw tokens, you have to call this function with the pool ID to know the ID, the pool we are referring to, and then you have to tell the smart contract how much, because we've already done the calculation from our front end. So you have to tell the smart contract how much, because smart contract doesn't support decimal place, floating point numbers and all of that. So we did the calculation from the front end, and then you have to pass in the password to make sure that this transaction is coming from the website. Okay, so that is it. So now the mistake was that this transaction was already public on an explorer. So if you look at when he clicked on decode data, obviously he saw the pool ID, which is 1, and then the amount for this transaction, and then the nightmare, our password is visible. So if you look at this string here, it's the same thing with what we have right here. So these are our password that we had in our React app, and we believe no one knows about it. But once the transaction was decoded, it showed up here. So all he had to do was to copy the password to some place, and then he went ahead to create his own React app. He doesn't even need to create a React app. He could just use Remix, but I believe he created a React app because he didn't have the source code for the smart contract. So to use Remix, you need the source code. So since he didn't have the source code, because we didn't publish that source code on BSC Scan, so he just created his own React app using the ABI from our website, and then he called the withdraw function from his own React app, and then he passed in when he was calling that function, he passed in the pool ID, which was 1, and then he passed in the entire contract balance. Okay, he passed in the entire contract balance as his amount, and then he passed in the password that he just copied from here. And once he did that, he was able to withdraw. How? Pool ID is correct to be 1, amount any amount can be passed, so he passed in the entire contract balance. Okay, and then he passed in the correct password. And what that meant was that he was able to withdraw all of the tokens that were kept in the contract. So you see, such a simple hack, but it's an expensive mistake. So the next thing is, how can we possibly prevent this kind of hack? How can we possibly prevent this kind of hack? The first thing is, never store your password in a smart contract. Don't store password in a smart contract, because even if the password is stored as a private variable, it can be decoded, it can be seen. So don't store your password on a smart contract. The whole password system might work effectively for the Web 2 space, but it doesn't work for the Web 3 space. So avoid storing that. This function should only be used, the keycac 256 should only be used to compare strings, but shouldn't be relied upon for password. So don't do this. That's the first step. Don't do this. The second way to prevent this kind of attack is for transactions like this. There are certain transactions you should not allow smart contracts to carry out. You should make sure that the address that, because the hacker actually did this through a smart contract. He didn't want to do it through his personal address because he could be tracked. So he deployed a smart contract, did the hack, and then destroyed the smart contract. Okay, so can I get that transaction? Let me see. Let me see if I can get that transaction. No, I don't think I can still get that transaction. Let me see. Can I still get that transaction? Okay, I couldn't get the transaction that led to that particular hack. I think it has gone down. But what I'm saying is that the hack was actually done through a smart contract. It was okay. I think I've seen this. Let me see. Let me see. Okay, this. Let me see. Okay, this is one of his addresses. He used an address to make these exploits. Let me see. Okay, trying out that I actually took note of the address that was used. Okay, I think this. Let's open this up and see something. Alright, if you look at this address, this was the address he used to exploit. You can see it is a contract. So he didn't do this from his private address. He deployed a contract for the purpose of these exploits. Okay, he deployed a smart contract for the purpose of this exploit. You can see from here where he was he actually Okay, the smart contract, you can see here, this is our smart contract sending him tokens, and then this is him sending out the tokens to his personal address. This is his personal address now. Okay, so you can see this is, he used the smart contract to withdraw the tokens. This is it, from our smart contract to his own deployed contracts right here, and then from his own deployed contracts to his personal address here. So what I was trying to say is, there are certain transactions on in your contract that you should not allow other contracts to carry out. You should, because when they want to exploit your contract, a hacker would not really use his own address. He would most probably use a contract address so that he can destroy. You can see after he carried out that transaction and stole all the funds, he moved out the funds from his contract to his own address, and then he destroyed the contract. You can see this says self-destruct. Okay, so that is why they don't want their address to be tracked. So they are going to use a smart contract. They are going to use another smart contract to attack your own contract, and then after they have done that, they will move the tokens to their own wallets and then destroy the smart contract. So the question is, how do you prevent a smart contract from carrying out certain transactions on your own smart contract? Because that's our second step. If you look at this new contract we deployed here, let me get it. Okay, now this is a new contract. Now you should, in order to do that, you should use a library, the address library. The address library, I am going to leave, is actually a library from OpenZeppelin, so I am going to leave the link in the description. So now this library has a function that checks whether an address that is initiating whether the address initiating a transaction is a contract or not. So you can see this function on the address library says is contract. So it checks whether it is a contract or not. How do you use this? Of course, you import it into your contract, or just put the code this way. And if you look at the new implementation that we did, we actually got a lot strict, and we had to correct some things. So let me get the withdrawal. All right, so I'm not really interested in this. Let's see this one here. Okay, so this is our new withdraw function. Okay, our new withdraw function now takes in just the pool ID and the amount, no more password. Instead, what we did is that first we use the address library. When you import the address library, like I said, I will be putting the link in the description. You can use it this way, where are we using that? Okay, let me see. Okay, so using address for address. So once you do this, you have declared this address variable here now to be used on addresses. So now on our withdraw function, we have now implemented that library. We are saying require that address dot is contract, require that the message sender, whoever is initiating the withdraw transaction withdrawal, is not a smart contract. That's what this line is now checking. Require that it is not a smart contract. If it is a smart contract, the required statement is going to prevent the transaction from going through. Instead, the person will receive an error that says something is not right here. So that's the first step. Second step. Make sure that in your smart contract there are certain functions that you should not allow another smart contract to call, because these hackers are not going to exploit your smart contract with their personal address. They will exploit it using another smart contract. So the very important step for you is to make sure that it is not a smart contract. That is it. So we have other things implemented here, and you can also implement a limit on how much can be moved out if you're doing like a staking contract. You see, like here we are saying that the amounts to be withdrawn shouldn't be more than multiply, like percentage. Maybe it shouldn't be more than 100% or 200% of the total amount the user staked. So that means even if the user goes back, if the hacker goes back now and passes an amount, he is going to be stopped right here. If he passes the entire contract balance, he's going to be stopped here, because this checks if he actually, the amount he's staking meets the condition of not being more than 100% or 200%. So that's security. But most importantly, what I'm trying to show you here is this address. Make sure that there are some certain functions in your smart contracts that a regular address, only regular address should call. Smart contracts shouldn't really call some of these functions. So first step I said is make sure you don't store password in your smart contracts. And next step I said is make sure that your smart contract is not being called by another smart contract for critical functions like this. There are other hacks that could be done on a smart contract, but I am not going to be discussing that right now. I'll be discussing that in subsequent videos. So that is why if you are not subscribed to this YouTube channel, you are making a big mistake. If you are a developer or wishing to learn or kind of interested in anything programming, then you should subscribe to this channel, please. Now, the third step is to make sure that any function that transfers tokens from your smart contract, make sure the function is private. I will explain that. Let's go back to our previous contract, which is this one. There is a problem here because this contract is external. If you look at that, it's external. Now, in this same contract, we are initiating the transfer of tokens, because here we are saying require transfer tokens, so we are sending the tokens in this same external. So it is not safe this way. What you should do is to move this actual line that is transferring tokens into your to a user, move it into a separate function and make the function private. This is what we did here. If you look at, after all of the checks have been done, after all of these checks has been done, we now called move tokens. We now called another transaction, another function that actually moves the tokens. That is to ensure that all of these requirements here must be met before any tokens are transferred. That is why we made the checks here, and then we now call this function. Instead of just putting the transfer directly here in this external function, we created another private function and then called it here. Private functions are functions that can only be called from this within the smart contract. So another external user will not be able to call this function. Let's look at the function. If you look at the function, of course, it is a private function. So this is what you should do. So first step, don't use password in your smart contract. Don't use password to validate transactions on your smart contract. Second step is make sure that your smart contract is not being called by another smart contract. And then third solution is move every function that transfers tokens out of your contract, move them to private functions. Don't make them public. So that is that. If you have any question, please, you can ask in the comments. If you have other suggestions, please, they are welcome. You can ask in the comments. And please don't forget to like this video, share it to save someone, and also subscribe to gain additional knowledge, because I will be discussing everything about my programming journey on this YouTube channel. So please make sure you subscribe to this YouTube channel and turn on the notification bell. And very importantly, please share this video. I don't want any other developer to fall victim of this. Please save someone today by sharing this video. Very, very important. People really need to see this. Okay, please save someone by sharing this video, because the Web3 space is really vulnerable. So I don't really want anyone else to have this sad experience that I had. So please share this video, share it everywhere so people can see and take caution. Now, you watching this video, if you have any vulnerabilities in your smart contract, please go and fix them. And I need to mention something very important before I go. Now, please learn how to use ChatGPT to validate your contract code. I mean, after you have done all of your checks, try to also take these functions and put them into ChatGPT and make sure they are safe. Okay, for example, if I call on my ChatGPT, if I open my ChatGPT, you can see I had to make sure that, you know, my function is safe. You can see I told you to explain, this is my private function. I told you to explain it. You know, I told you to explain my private function. I pasted the code for it, and you can see it gave me a concise, very comprehensive explanation of what the smart contract does. I could as well just ask it, is this contract, is that particular function vulnerable? Because I cannot really deny the fact that ChatGPT helped me to figure out how exactly the hacker was able to exploit that withdraw function. I think, do I have it somewhere up here? Because when that hack actually happened, you know, I just poured my frustration on ChatGPT, and I was just asking questions. How comes? How was this exploited? Blah blah blah. And you know, thankfully, ChatGPT was able to tell me, hey, this was how it was done. And when I went back to look at it, I found out that it was true. That was actually how the hacker exploited my contract. So please learn. As a developer, you need to learn how to use ChatGPT. Now, I'm not saying you should rely on ChatGPT 100% to validate the security of your contract. No, but ChatGPT is actually a very great platform, at least that could start you up, like give you suggestions on what to do, you know, on how to start. It can actually give you a brilliant idea, suggestion on something. So I use that a lot to these days to validate any code that I write, because there are certain things that you may not notice, but certainly AI will notice. You can see here I say here help run a vulnerability check on the following code, and I passed my new withdrawal function to it, and within seconds ChatGPT was able to give me a comprehensive report. Thankfully this time it says the code appears to be safe and there are no obvious vulnerabilities. So if I had done this previously on the other contract, I would have saved myself the pain of getting hacked and losing $3,000. So please, as a developer, know how to use ChatGPT. So that's all about this video. It's already getting too long. I mean, it's getting too long, too lengthy than I had planned it. But of course, it's very important to save you. So please, like I said, share this video. Share it now, not tomorrow. Share it now so that another person can, see it and learn. Thank you so much for your time, and of course I'll see you in my subsequent videos where I'll be discussing my programming journey. Bye bye.